Welcome to this topic, Earth geometry. So the way we're going to discuss this topic, we're going to first study the Earth as a sphere. We are going to take a look at various parts of this sphere. Once we get done, we're going to take a look at position of a point. Then we'll move to distance along small circles and distance along great circles. Then we'll end this topic with speed and time. In this video, we're just going to take a look at Earth as a sphere and position of a point. In the next video, we're going to take a look at distance along small circles and distance along great circles. Then we'll end with the last video that's going to concentrate on speed. And so this is the wire mesh view of the Earth as a sphere. So the important points are the bottom of the Earth is called the South Pole, and the top of the Earth is called the North Pole. Other than this, the Earth has imaginary lines. The first type are called longitudes, which move from bottom to up or up to bottom. You can view them to be more like the y-axis of the x or y plane, which move up, down. Then the Earth also has a center. Then other than the center of this Earth, there are also lines that move left to right. These ones called latitudes. So latitudes, you can view them to be more like the x-axis or the x lines on the x or y plane. So this is a latitude, this is a latitude. Any line that moves from left to right or right to left is a latitude, and any line that moves bottom up or up bottom, it is a longitude. The Earth being a sphere, it has a radius. In short, it is made of circles. So these circles have a radius. So the radius of the Earth, which is the distance from the center to the North Pole, or the center to one of the longitudes, or the center to all the latitudes, is 6370 kilometers. So this is one of those numbers which you are going to use in our. So there are two types of circles. All the circles on the Earth, like I said, others can be viewed as more like the X, the others can be viewed more like the Y. But there's another way to classify them. The first type are called small circles. So small circles are all lines of latitude apart from the equator. The center of all the lines of latitude, this one is called the equator. So the equator is a great circle. It's not a small circle. Other circles are called small circles, but the equator and all the latitudes are called great circles. So the equator and all the latitude, this one, any line that goes up down is called a great circle. So remember, left right, small circle, up down, great circle. Other than the equator. The equator is the only one which goes left right, which is a great circle. So this is the equator. So these lines are measured in angles, like degrees. So the equator is at 0 degrees. The very important line among the longitudes which go up down is called the Prime Meridian or the Greenwich. So this meridian line also has a 0 degrees. So when measuring, we start from the meridian, then we go this side or this side. Then for latitudes, we start from the equator, we go up or down. Next, we're going to take a look at how to measure angles. So the angles between 2 points, which is termed as angular difference, or the difference in angles between 2 points, is measured like this. So let's say this one, let's remember that it is the 0 degrees longitude, the meridian. So if, for example, there is a point here and a point here, so the difference in the angles, because these lines these points are lying on the longitudes but on the same latitude. So this is the same latitude they are lying on, then the longitudes are different. So the difference in angles between these places is the difference in the degree of this longitude and of this longitude. In essence, it is the measure of this angle here. Okay, So if we draw straight line from the 2 points, we go to the center of the earth, the angle they make is what we actually call the angular difference between the points. So if this is 30 degrees, then these 2 points are 30 degrees apart. And since the meridian is 0 degrees, it means this other one is going to be 30 degrees. And the left side of the earth is the west, the right side is the east. So since it is on the left side of the meridian is this one, the left side is here, so this is 30 degrees west. If it was on the right, then it could have been 30 degrees east. So this is the counter example where I've got that small angle there. Let's say it is 10 degrees, then the point or this longitude is 10 degrees east because it is on the right of the meridian. The same is true for lines of latitude. We use the equator as the center or as the point of measurement, like the 0, since equator is 0 degrees. So this angle, which is the angle between the equator and this line here, so this angle, let's say it is 70 degrees, it means that line on top is also 70 degrees north. The upper part of the earth is north, or the upper part of the equator is north, then the lower part is south. Then the counter example is that angle which is between the equator and on the lower part of the equator here. So this latitude is on the south. So if that is 10 degrees, then this is 10 degrees south. So here is some facts you can keep up. The maximum possible longitude is 180 degrees west or east. So if we start doing the measurements from 0, the furthest we can go is 180 degrees. We don't go there. Among the longitudes, the great circles, the ones that move there, that moves up to down. Then on the latitudes, the ones that move left to right is 90 degrees. We don't have a latitude that is greater than 90 degrees. No. Next, we study position of a point. Just like on the graph or on the x or y plane, the position of any point is given by the x value and the y value, as in x, y, or 2, 4, 3, 6, and the likes. So the position of any point is given by, first you state the latitude where that point lies, then you state the longitude. The latitude is more like the x and the longitude is more like the y, like I had said. Both should be expressed in degrees, or sometimes they can be expressed in minutes. There is a good relationship between degrees and minutes, and the relation is 1 degree is equal to 60 minutes. So sometimes they are expressed in minutes. So here's an example. Osaka is located on latitude 15 degrees south and on longitude 28 degrees 20 minutes. So to state the position of Osaka, we just write first the value of latitude 15 degrees south, then the value of the longitude 28 degrees 20 minutes east. So here it was supposed to be east here, that's why it is east. I forgot to put the east here when writing. So sometimes if you want to convert minutes to degrees, you can use this conversion. 1 degree is equal to 60 minutes, or you can just divide this by 60. You're going to get 0.33, then you can add this 0.33 to 28. You're going to get 28.33 as your longitude. Now there is a special skill of getting the angular difference. Once you know the position between 2 points, it is required of you to calculate the difference in the angles between those points. So there are some 4 rules that we need to learn. The first 2 rules have to do with points that are on different longitudes. So for lines on the same side of the meridian, again the meridian, let's say this is the meridian, we use it as a reference when calculating the angles. So for lines that are on the same side of the meridian, this side, the other side of meridian, of course, is this side. So for lines that are on the same side of the meridians, the difference in angles is found by subtraction. So if points are on the same side, you subtract them to get the difference. So get the bigger number, you remove the smaller number. Here, for example, we have 45 degrees west and 15 degrees west. So 45 minus 15, we get 30 degrees. That's the angular difference between these. Then the second, again, which has to do with longitudes, for lines on the different side of the meridian. So lines that are on the different side of this prime meridian, the center, like this one is this direction and this one. To get the angular difference, you add them. So you add 45 degrees west plus 15 degrees east gives you 60 degrees. That's the angular difference if the lines or the points are on the different side of the meridian. The third rule has to do, the third and fourth rule have to do, they have to do with latitudes. So for latitudes, again, we start again. For points that are on the same side, this side, or both are this side, so long as they're on the same side of this equator, then to get the angular difference, you subtract, as in here, 90 minus 85, it has given us 5. Then the opposite is when the lines or points are on the different side of the equator. One is on the north, the other one is on the south. So when they are on the different side, you add them. So 90 plus 25, 115 degrees. So let's do this exercise. So I've got these points A, B, C, D, E. So the question is, describe the location of the points A, B, C, D, and E. So the question wants us to just state the location, as simple as that. We start with the latitude value, then we get the longitude value. So for A, it's simple. A is here. So what's the latitude? The latitude is here, is this one, which goes left, right. So if we follow, it's 90 degrees. Then the other line that passes through A, it is this one, which is the longitude, which is 65 degrees west. So it's 90 degrees north, 65 degrees west. Next, B. B again, it is on the same 90 degrees. So it is 90 degrees north. Then longitude, it's 0 degrees. So it's 90 degrees north, 0 degrees. C still is also on the 90 degrees north. So we're just going to get the longitude, which is 10 degrees east. So 90 degrees north, 10 degrees east. D. So D is here. What is its latitude? So if we follow, it's 80 degrees north. What about longitude? The longitude is this one, 10 degrees east. So it's 80 degrees north, 10 degrees east. E. So if we go here on E, if we follow like this, we can see that the latitude for this one is 25 degrees south. What about the longitude? The longitude, to follow this line, it's 10 degrees east. So this is how to state the position of the points. Next, maybe we do an exercise or an example, to be specific, that is concerned with the angular difference. So question 2 says, find the differences in latitude between C and D. So they want us to state the difference in latitude between C and D. Okay. Also C and E. C and E. So we start with C and D. So what's the difference in latitude between C and D? Latitude, we're talking about these ones that move left to right. As you can see, the longitude, C and D are on the same longitude. That's why we are interested in the difference in latitude. So the first question is, are they lying on the same side or on different side of the equator? Latitude is the equator. They are lying on the same side, the north. Therefore, we are going to subtract. A simple key, sometimes because you can be asked without a diagram, when the direction are the same, if both are north, subtract. If they are different, add. So 90 degrees north for this latitude and 80 degrees north for this latitude, so you subtract. So 90 degrees north, 10 degrees east, and 80 degrees north, 10 degrees east. So since they are the same, like I said, if they're the same, subtract. So we're going to subtract. Difference is 90 minus 80, which gives us 10 degrees. C and E. So C again, we know it's 90 degrees and 10 degrees east. E is 25 degrees south, 10 degrees east. So as we can see, they are on the different side of the equator. This is the equator, one is up, the other is down. So we have to add. Again, using that technique which I had shared, C is this and D is this. Then you look at the latitudes, they are different. If they are different, it means add them. So we're going to add. Difference is 90 plus 25. My bad, it's supposed to be 25 here, not 80. So it's supposed to be 25 here, which should give us 115. Anyway, it was a mistake. The next question is find the differences in longitude between A and D. So they want the difference in longitude between A and D. Also C and E. C and E. This time in longitude. Meaning that the line that goes up and down. But C and E, as we can see, they are lying on the same longitude. So this is going to be tricky because there will be no difference. But then we hope there is no mistake again. So we start with A and B. So first we write the position of A and B. Or before you can do that, you can ask yourself, where is the meridian? So the meridian is actually here. So here, since the meridian is 0 and A is here, so if we ask ourselves, are they on the same side? Since the meridian is 0, it has no impact. Okay, so if we add the value here and the value here, or we subtract the value here and here, there will be no change. So it doesn't matter whether to say they're on the same side or different side. The answer is going to be the same because this is 0. It's the center of measuring whether they're on the same side or different side. So A is 90 degrees north and 65 degrees west. Well, B is 90 degrees north and 0 degrees. So if we use actually here we're concerned with the longitudes, these ones. So since we don't have direction here, we can do anything, the answer will be the same. So here I chose difference. 65 minus 0 is just 65. A and E. So it was a mistake. It was supposed to be A and E. So yes, the first question was it was supposed to be A and B. Then the second A and E, not the way I had written them. Okay, hope you bear with me. I might have confused you there because I started with A and B, which wasn't even in the question. So A and B was the first question, which we have calculated. Next is A and E. So what is the longitude of A? So what is the position of A? A is 90 degrees north, 65 degrees west, and E is 25 degrees south, 10 degrees east. We are concerned with the longitudes, these ones. So the longitudes, if we see here, they are different. One is west, the other one is east. Even from the diagram, using the 0 degrees, the 0 degrees meridian, this one is this side, the other one is this side. So meaning that we add. So difference is just the summation, 65 plus 10, which gives us 75. So this marks the end of part 1 of Earth geometry. Hope you have learned a thing or two. Happy solving.